Pyramids. So a pyramid is a solid with a polygonal base, so a two-dimensionally shaped base, a polygon, meaning it has straight sides, and triangular sides that meet at a point called the apex. A right pyramid is one in which the apex is directly above the centre of the polygonal base, and a non-right pyramid is called an oblique pyramid. The height of a pyramid is the vertical distance from the apex to the base, and that height should be perpendicular to the base. Pyramids are also named according to their base shape. So the one pictured here is a square-based pyramid or a rectangular-based pyramid. Here we have a collection of pyramids. We have a hexagonal pyramid, a rectangular pyramid, a pentagonal pyramid, a square pyramid, and the last one here at the bottom right is an oblique rectangular pyramid. And the clear thing is, and I didn't actually mention this when you're talking about oblique prisms, is that the formulas for finding surface area, simply adding up the areas of the surface area, but volume is exactly the same. So volume of a prism is area of base times height. That's the same whether it is a right prism or an oblique prism. The key is that the height is perpendicular to the base. So on this pyramid, for example, the height would be this vertical distance that if I drop it to the ground is at a right angle to the ground. Okay, so surface area of pyramids. Obviously surface area is the same, we're just adding up the surfaces. Certain shapes are going to require more work to do that than others. Here we don't have any curved surfaces, we're just dealing with rectangles and triangles. So the key thing though is to recognise here is that it's a rectangle on the bottom and not a square. That means we have two differently sized triangles. We have a triangle with a base of 7, and we have a triangle with a base of 8, and then we've got the square on the bottom. So our surface area here is going to require, the rectangle. It's going to require us to add together the rectangle, which will be 8 times 7, there'll be two triangles that have a base of 7, and there'll be two triangles that have a base of 8. Now obviously we're going to need to know the heights of those two triangles. So that is this length along the side with the triangle with base 7, and also this length along here with the triangle with base 8. Okay, so here we're going to need to think about, we know about the height, which is the perpendicular height. So this distance straight down to the centre, we know that that's 12. So if I want to then think about, first of all, let's look at this right-angled triangle here. Okay, so I'm going to draw that out. So I've got the height of 12. This is the length I'm trying to find, and that base length of that standing up green right-angled triangle is half of 7, so 7 on 2. Remember, best to stick with fractions if we're going to be squaring them. So Pythagoras' theorem here, x squared is 12 squared plus 7 on 2 squared, so 144 plus 49 on 4. 144 is the same as 576 on 4. So we can do 4 times 100 plus 4 times 40 plus 4 times 4 to get to 576 plus 49 on 4. So that is 625 on 4, which means x is the square root of that, and both of those are square numbers. 625 is 25 squared over 4, which is 2 squared. So square root of 625 on 4 will be 25 on 2. So that's going to be the height of the triangle with a base of 8. So that is 25 on 2. And then if we also think about the other triangle's height, so looking at this orange triangle that I'm now drawing in, I'm going to try and squeeze that in down here or we're going to run out of space. So we're going to have the height is 12. The hypotenuse is unknown. I'm not going to use the letter x again. X has already represented a length, and it is different to the length that I'm trying to find now, so I'm using another letter. The base of this triangle will be 4. So we know here that y squared is 12 squared plus 4 squared. So that's 144 plus 16, which will be 160. So y is the square root of 160, which is going to be, 4 root 10. Alright, so that is this height here, 4 root 10. Okay, so now we have all the information to find our surface area. We have a rectangle 8 by 7 plus 2 triangles, so 2 times half times 7 times 4 root 10, plus 2 of these triangles, so 2 times half times 8 times 25 on 2. Again, I'm going to stick with fractions rather than decimals. It's easier to multiply them together. So 8 sevens are 56. The 2 times a half is 1, so that cancels out. We've got 7 times 4 root 10, which means that I'm going to have, 28 root 10. Plus, again, 2 times a half cancels out. We've got 8 times 25 over 2. The 8 we can cancel down with the 2 on the denominator to just do 4 times 25, so that's 100. So we have 156 plus 28 root 10. That is the exact answer. The units on that are centimetres squared. It's the surface area. And if we put that in our calculator, we can work out that our answer is 244.54, again, centimetres squared. Okay, so volume of a pyramid. So to find the volume of a pyramid, we have to first consider the corresponding prism. So that is the prism with the same base and the same height. And when we do that, and via experimentation, and if you actually type into YouTube volume of a prism and pyramid or something like that, you'll get a number of different videos that illustrate this through experimentation. So for example, taking a prism, a square-based prism and the same base and height pyramid, and looking at how many different, if you fill up the pyramid with water, how many of those do you need to be able to fill up the total prism. And it turns out that you need 3, which means that the pyramid is 1/3 of the volume of the prism. Okay, so if we have a look at this, it's the same solid we were dealing with before when we found the surface area. So the volume of the pyramid will be 1/3 of the volume of the prism, with a rectangular base of 7 by 8 and a height of 12. So that means that our volume is going to be 1/3 times 7 times 8 times 12. Now obviously you want to use that third in as convenient a way as you can, so 1/3 times 12 I can work out, so let's do that first. 1/3 times 12 is 4, and then we've got that times 7 times 8. So 4 times 7 is 28, and then multiplying that by 8 gives us 244. Or you might find it easier to do the 7 times 8. So for example, 7 times 8 is 56. 4 50s are 200 and 4 6s are 24, so we have 224. Units here are centimetres cubed. It's a volume. Alright, now third example, if this pyramid pictured, so it's a hexagonal based pyramid, has a base area of 12 and a volume of 180 centimetres cubed, find its height. Okay, so we know for any pyramid that the volume is 1/3 times the base area and times the height. So that means in this case we know about the volume, we know about the base area, and it is the height that we don't know about. So we have 180 is 1/3 times 12 times some unknown height, and we can solve for h. So 180, 1/3 times 12 is 4. So h is 180 over 4, which is 90 over 2, which is 45. It's a height, which is a length, so the units are just centimetres. So in summary, the surface area of a pyramid, like any other surface area, is the sum of the areas of all the surfaces. That might require some Pythagoras to work out heights of triangular sides. And the volume of a pyramid is 1/3 times the volume of the corresponding prism. That is 1/3 times the area of the base times the height.